Okay, this video will help you understand how to find sine, cosines, and tangents, find trig functions essentially, for any point in any quadrant on a graph. Usually when they give you a point, they're going to ask you to draw a triangle, essentially straight from the origin to that point, and then drop an altitude down from that point directly to the x-axis, again forming a reference angle for theta. So for this first triangle that we've got here, notice that our point is at 3, 4, which means that our side lengths essentially are 3 for your x-axis and 4 on the y-axis. Now you might remember from geometry, but 3, 4 essentially makes a 3, 4, 5 triangle. But if we did a little Pythagorean theorem, you quickly figure out that that r, that radius, if we did form a circle, right, around here, through this point, the radius of that circle would be 5 units. Now you can quickly find the sine, cosine, and tangent. Again, you've got theta as a reference point, and so the opposite is 4 over the adjacent being 5, or sorry, the hypotenuse being 5, 4 over 5. Cosine is your adjacent over hypotenuse, 3/5, and tangent being 4 over 3, or your opposite over adjacent. The other three trig functions essentially just come down to flipping those over. They're just the reciprocals. So secant is reciprocal, remember, of the cosine. Cosecant reciprocal of the sine. Oops. Although we actually have to find the reciprocal. So I'll go ahead and flip that over. So since the sine was 4/5, we're going to get 5 over 4. And cotangent reciprocal of the tangent. So 3 over 4. Now you'll notice on the right we've got that almost that same triangle drawn, only this time we're down in the third quadrant. So this is going to illustrate for us that essentially you've got the same size triangle. The difference is now we've gone to the left and down, or basically formed an angle from the positive x-axis all the way around that we could call theta. But the triangle formed uses that reference angle again, uses theta prime. And because theta prime and theta over here at the left drawing are basically the same, they both have side lengths of 3 for your x value and 4 for your y value. They're both going to have a radius or a hypotenuse of 5. They should essentially have the same sine values. The opposite is still 4 over 3. Or sorry, the opposite is still 4 over 5 for the sine. But now realize that because we went downwards, we are going to have negative length, and that's sort of a new idea. That reference angle formed essentially will have all the same values, again with the exception of those positives and negatives. You can have negative side lengths on a triangle if it's in the third quadrant or even the second or fourth quadrants. So the sine becomes net 4 over 5, but because of the negative, we're actually negative 4/5, and thus negative 5/4 for the reciprocal. Tangent of theta, again, will be opposite over adjacent. So you've got a negative 4 over negative 3. Well, negative over negative actually becomes positive. So even though we're down in the third quadrant, we've gone left and down, the tangent actually becomes a positive number, and thus the cotangent being a positive 3/4. But notice again over here, tangent was 4/3. Over here, tangent is 4/3. Because essentially the triangle again was the same. Cosine is going to be adjacent over hypotenuse, so again negative 3/5, okay. And the secant then negative 5/3, just a reciprocal of that. Again, you'll notice that opposite of theta and opposite theta prime will always be that y coordinate. Notice from our coordinate over here that up and down, because the reference angles to the x-axis, your y value always becomes the opposite. So because it's the opposite here, the sine will always take on the y value, y over r. And we can kind of illustrate that with our chart down here. Sine essentially corresponds to your y coordinate, cosine your x coordinate, because again it's the adjacent, and using that x-axis as part of our reference angle, the adjacent will always be that x coordinate. And tangent becomes y over x, the opposite, or the y coordinate over the x being the adjacent. Well, we can use that for various points and angles. So we've got negative 5/12. So again, first thing we would do is draw ourselves a picture. We've got -5 units, so there's the side of my triangle. I'm going to go up 12 units, and then we're going to connect that, again calling this our theta prime, using our right angle here. We've got up 12. If you do a little Pythagorean theorem, 12 squared plus -5, the quantity squared, equals c squared. C squared will be equal to 169, which makes c, or as we called it before, our r value, right, into a 13. And again, we can lay out the sine, cosine, and tangent for theta. Remember that theta technically goes from the positive x-axis, but theta and theta prime will again have those same values. They have the same sine, cosine, and tangent values, again with exception of sine, with exception of the positive or negative sign in front of our figures. So take a second and go ahead and find those three parts. Okay, I've got those values given to you down below. Hopefully you came up with the same things. One thing you do want to note, and it's just a good way to double check your answers, kind of a checkpoint of things, is a little figure we sort of refer to as SATC. It's not only a graph but a sort of a plus sign. It'll tell you which trig functions are positive where. And because we're in the second quadrant, the sine being the y coordinate, again we went above the x-axis, so the sine will be a positive value, but none of the other two, neither of the other two will be positive. So notice we got negatives on both of those. If we refer to the figure, it kind of makes sense why. So let's do the same thing over here. Again, we've got our values, so -4, we're going to go up 4 and connect that directly back to the axis on there. So go ahead and take a second, do your Pythagorean theorem, and fill in the sine, cosine, and tangent values. Okay, so we've got our picture up top. Do a little Pythagorean theorem, again squared, square root of the 32, and you notice we just broke down that 32 using our root properties, and ended up with 4 root 2 as a hypotenuse. Then I laid out the sine, the cosine, and the tangent. Realized that for the sine you've got 4 over 4, which leaves you with a 1 on top. But again, we don't like that root on the bottom, so we need to do a little rationalizing the denominator, and you'll end up with a square root of 2 over 2, which is a value you might recognize from your unit circle. Remember, if you have equal side lengths, sides of 4 and -4, essentially the same value of 4, you've actually got a 45, 45, 90 triangle. So you just figured out that the sine of 45 degrees is root 2 over 2. When you're in the second quadrant, though, remember that cosine from SATC is going to be a negative value. So again, though, we get to value or cancel our 4's, do a little rationalizing, and you'll find out that negative root 2 over 2 will be your cosine value. Again, because you're in that second quadrant, cosine's a negative value, but it's still the cosine at 45 degrees, just the negative value of that. And tangent, again, is 4 over -4. Cancel your 4's, you end up with -1. Also, something to realize is that the sine divided by the cosine will be equal to the tangent. So this value divided by itself, only negative, will end up giving you that -1. Again, 2 more examples on the next page. Go ahead and try them out, and I will fill in the answers for you here in just a minute. Alright, over here at the left we've got our drawing made, and I realized that when I wrote that down, my opposite was 1, my adjacent was root 3, which made me think of a 30, 60, 90 triangle with a hypotenuse of 2. Realize that our reference angle is 30 degrees. If we actually look around counterclockwise from the positive x-axis, that makes a full angle of 330 degrees. So again, it's one of those 30-degree reference angles off your unit circle. So the sine of theta, the sine at 330, will be my opposite over my hypotenuse, or -1 over 2. Cosine, again at 30-degree reference angle, 330 degrees, is the adjacent over the hypotenuse. And down in quadrant 4, the cosine is what's positive. Remember, SATC, cosine being the only of the positive values. And finally, the tangent, from our picture, will be the opposite over the adjacent, -1 over root 3. Again, the same thing you would have gotten by dividing the sine by the cosine. You can imagine multiplying the reciprocal of the cosine and your 2's will cancel. Feel free to lay that out and watch it happen. But if I rationalize the denominator, again, multiply the top by root 3, multiply the bottom by root 3, and you will have a good tangent value. Over here at the left, we have a slight problem in that if we graph the point -1, 0, we won't be able to draw a triangle. But realize that this is a 180-degree angle, which means a triangle doesn't really make much sense anyway. But do realize you have a -1 for an x value, a 0 for a y value, and if we think about it, how far from the origin are we? R, or that radius of the circle around the origin through that point, is equal to 1. So we can still define the sine as the y-coordinate divided by r, cosine as your x-coordinate divided by r, and tangent as y over x. And you'll find out the sine at 180 degrees is 0, cosine is -1, and the tangent is also 0. At the top, it asks you for the 6 trig functions. Remember that all you need to do is for the sine, cosine, and tangent, take the reciprocals of each of those values. So we can go back here and quickly fill those in. Secant of theta will be equal to the reciprocal of the cosine. So 2 over root 3, but remember if you put a root on the bottom, I'm going to multiply both top and bottom. And you should end up with 2 root 3 over 3. Cosecant, reciprocal of the sine, so simply -2. And cotangent, which is reciprocal of the tangent, well, go back to the original. If I take the reciprocal of -1 over root 3, I will just get simply -root 3. Over here at the left, or at the right, it gets a little bit trickier. For the secant, you're taking the reciprocal of the cosine, so reciprocal of -1 is -1. But for the sine, the reciprocal of 0, well, think about flipping over 0 over 1 becomes 1 over 0, which is actually undefined. Because again, you got that 1 over 0. And cotangent runs into the same problem. Right now I've got 0 over -1, so I'm going to end up with -1 over 0, which again is undefined. I hope that helps you with the trig points in any angle, and again, have fun.